Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May June 2023 paper 4 variant 2. In this lesson, our main focus will be on ideal gases, means simply we can say thermal physics. We will also talk about thermodynamics. We will also discuss about simple harmonic motion in today's lesson. So we will be solving second question from this paper, third question and fourth question from this paper. Second question is about ideal gases and third question is about thermodynamics and fourth question is about simple harmonic motion. And these three topics are very important for your exam. Every year you will see one question from simple harmonic motion, at least one or two questions from thermal physics. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these questions. Let's study together, let's improve together. Question second, part A says, what is meant by an ideal gas? Ideal gas has to be PV is equal to nRT at all values of P and all values of V and all values of T. And T is thermodynamic temperature, or simply we can say T has to be in kelvins. Let me show you how you can write down your answer. For the answer of this question, simply you can say a gas that obeys PV is equal to nRT for all values of PV and T. And you have to write down temperature has to be in Kelvin. Or simply you can say T is thermodynamic temperature. So you will get 2 marks. So in this case you can see first mark is the M mark. This has to be in your answer. If this is in your answer and you have also written T is the thermodynamic temperature, you will get 2 marks. For the second part, we need to state the temperature in degrees Celsius of absolute zero. Absolute zero, when we state for A2 physics, we have to state this one up to 2 dP. So it's very important when you write down thermodynamic temperature, it has to be up to 2 dP. If you write down 1 dP, you will lose marks. Mean you will not get this mark. Part B says a sealed vessel contains a mass of 0.0424 kg of an ideal gas at 227 degrees Celsius. The pressure of the gas is 1.37 times 10 to 5 pascals and the volume of the gas is 0.640 cubic meters, or simply you can say meters cube. For this question, we need to calculate the number of molecules of the gas in the vessel. Now you can see the beauty of physics. You need to count the number of molecules. So we can simply use PV is equal to nRT. So this is the beauty of physics. It's asking you to count number of molecules. Now simply we can use ideal gas equation and we can count number of molecules. We have the second form of ideal gas equation, that is PV is equal to nKT. We need to, in this case, calculate number of molecules. So we will be using this one. You can also use one, but it's better to use this one so you can get directly number of molecules. So we will be using here PV is equal to nKT. We need to calculate number of molecules, so this will be equal to PV divided by K times T. K is a constant, this is Boltzmann constant. Now simply we need to plug in values. Value of P we have, that is 1.37 times 10 to 5 and value of V is given, that is 0.640 divided by K is a constant and its value is 1.38 times 10 to negative 23 times. We have temperature, it has to be in kelvins because given temperature is in degrees Celsius. So we have to convert this one into Kelvin. So we have to add this constant 273. Now if we solve this one, we will get 1.27 times 10 to 25. So these are the number of molecules of the ideal gas present in the vessel. So simply we can say 1.27 up to 3SF times 10 to 25 number of molecules in the vessel. So you can see the beauty of physics. We have set these rules now. So you don't need to count how many number of molecules. It's not possible, that you can count number of molecules, but we can use these rules and we can calculate number of molecules. This question has 3 marks. The first mark you will get if you have written this equation, you will get 1C mark. And the second mark you will get if you have plug in these numbers, and the third mark you will get if you have got the right answer. So always start with writing the equation. Even if your calculations are wrong, still you will get 1 mark. 1 or 2 marks you will get depending on the question. For the second part, we need to calculate mass of one molecule of the gas. So we can simply say in this case total mass of the gas. So this is mass of the gas. This will be equal to number of molecules of the gas in the vessel times mass of single molecule. So we can say this is mass of single molecule. Now simply we need to plug in values. We have total mass of the gas in the vessel, that was equal to 0.0424 kgs. And number of molecules of the gas we have just calculated, that was equal to 1.27 times 10 to 25. Now we need to calculate mass of single molecule. Mass of single molecule. So from here, if we calculate mass of single molecule, means simply divide this one by this, we can calculate mass of single molecule. That one will be equal to 3.34 times 10 to minus 27 kgs. So this is mass of single molecule. So we can write down 3.34 times 10 to minus 27 kgs. And this question has only 1 mark. If you have got the right answer, you will get this mark. For our third part, we need to calculate the root mean square speed of the molecules of the gas. So we can start with kinetic energy, average translational kinetic energy of molecules, and this is equal to 3 by 2 K times T. T has to be in Kelvin, means this has to be thermodynamic temperature. And average kinetic energy of molecules, we can simply write down this is 1/2 m mass of single molecule time mean square speed. This is equal to 3 by 2 K times T. So we can simply cancel here this 2 with this. We need to calculate mean square speed, so we can write on here. So this one is the mean square speed, so this will be equal to 3 kT divided by m. This is the mean square speed, but for this question we need to calculate root mean square speed, so we can simply take square on both sides. So this is the root mean square speed. This will be equal to 3 kT divided by m. So this is mean square speed, so we have to take the root of this. So we will be taking root on both sides. So we can say this one is CRMS. Now simply we need to plug in values. We have value of K. K is a constant and this is Boltzmann constant. So we have 1.38 times 10 to minus 23, and temperature has to be in kelvins. Temperature given to us was 227 degrees Celsius. We have to convert this one into kelvins, and we need to divide by mass of single molecule. So m is the mass of single molecule, and mass of single molecule we have just calculated here. So this is 3.34 times 10 to minus 27. Now if we take square root of this one, our final answer will be equal to 2490 meters per second up to 3 SF. So this is our final answer. This question has 3 marks. The first mark you will get if you have written this formula, you will get 1 C mark. Mean if you have written this formula, you will get 1 C mark. And the second mark you will get if you have plugged in these values. You will get the second C mark, and you will get the final mark A mark if you have got the right answer. We can also approach this one using a different formula, but this one is quite straightforward one. We can do it with this. Part C says the gas in V is now cooled gradually to absolute zero. On figure 2.1, sketch the variation with thermodynamic temperature T of the RMS speed of the molecules of the gas. We have RMS speed on y-axis and we have temperature in Kelvin on x-axis. That we have already discussed that 1/2 m mean square speed this is equal to 3 by 2 k times t. We need to find the relationship between root mean square speed and temperature. So we can cancel this 2 with this 2. So we can write down the mean square speed in this case will be equal to 3 kt divided by m. We need to find out root mean square speed. So we have to take square root on both sides. Square root here. So if we rearrange this one, we can write down 3k over m, root of this quantity times the root of the square root of t. We can also rearrange this one more because this is a constant. This quantity is constant, mean 3k over m. This is constant. We can replace this one with another constant. We can say this is c1. And here we have square root of t. Now we need to understand what will be the shape of the graph if we have root mean square speed equal to some constant times square root of t. So in this case we can also write down CRMS. This is directly proportional to square root of t. So what will be the shape of the graph? First of all, let me sketch some graphs and let me ask you some questions because these graphs are very important. And also, if you're struggling with graph from A to physics, on my channel, I have uploaded a lot of questions, one full video, and that video has only questions from the graph. And if you watch that video, your concepts about graphs will be very clear. So imagine that we have on y-axis, this is y, this is x. If the line is a horizontal line, so can you write down the equation for this one? And now it is also possible in the exam you will see this kind of graph, or you need to sketch this kind of graph, means straight line. It is also possible in the exam, you will see this shape of the graph like this. And it is also possible in the exam, you will see this kind of graph like this. And it is also possible in the exam, you will see this kind of graph like this, very steep one. This is less steep and this one is much steeper. So let me redraw this one so you can get better. So this is much steeper. So can you write down the equations for these graphs? And also it is possible, you face this kind of graph, you will see graph like this. So this kind of graph. So here, this one. Now let's try to write down the equations for these graphs. You can try by yourself. First of all, you can pause the video, you can try to do by yourself. For this one, y is equal to some constant, and for this one, y is equal to c time constant, and for this one, y is equal to c time x square. This is linear graph, this is parabola, and for this one we have y, this is equal to c times 1 over x, or you can say y and x, they are inversely proportional to each other. And for this one we have y, this will be equal to c times 1 over x square. So this is inverse square graph. This is inverse square, and this is quadratic. And for this one, how about for this? So if this quantity is y, so this is y and this is x. For this one, y is equal to some constant times root of x, or we can say y square, this is equal to c times x. Now if you look at this one, this relationship, do you see any similarity between this one and this? They are the same. So it means the shape of the graph you need to draw, it has to be somewhat like this. And at this point, 500 degrees Celsius, we have already found the speed. That was 2490. So this is the root mean square speed, 2490. But you don't need this one for this question to answer. Simply you need to sketch. I hope you have some better understanding of graphs now. Third question, part A says, state the first law of thermodynamics and identify the meaning of any symbols that you use. So first of all, we can write down first law of thermodynamics. Delta U is equal to Q plus W. Now we need to identify the meaning of these symbols. Delta U is the increase in energy. So this is the increase in internal energy. Increase in internal energy if this is positive, and Q is thermal energy transferred. So we can say this is thermal energy transferred to the system. Thermal energy transferred to the system if you take Q is positive to the system. Or simply you can say thermal energy added to the system. And W, if we take this is positive, so this is representing work done on system. Work done on system, and system means we are talking about gas, work done on system. So if you write down delta U is equal to Q plus W, and then if you explain the meaning of each symbol, you will get 2 marks for this question. Part B says the state of an ideal gas is continuously changed according to the cycle ABCDA shown in figure 3.1. For part B1, we need to complete table 3.1 for the changes A to B and B to C by placing 2 ticks in each row. So first of all, from A to B. A to B mean for this process, or we can say for change from A to B. First of all, we will look at work done. So we have WAP. Here we need to write down work done on gas, means what is happening to work done on gas. So here gas is compressed, means volume is decreasing. So we can say this is P times delta V. So gas is compressed. So simply we can draw here. We have first of all piston. So this one is our piston and this is our cylinder. We have certain gas inside, and now we compress this one. So we compress this gas. So let's say we move this piston down. So piston is here now. So the gas has been compressed. As in this case, gas is compressed. It means work is done on gas, and work done on gas is positive. So that's all what you need to understand for A to B work done. Now let's try to find out work done between B to C. So we will go to next point, between B to C, for this process between B and C. Between B and C, we can write down work done. So this is between B and C. So we have value of P. P in this case is increasing. So we have increasing value of P. But how about the change in delta V? Delta V in this case is equal to 0. One thing you need to understand, this formula when we use actually, W is equal to P times delta V. This P is constant. So very important point you need to understand. For constant P you can use this formula, but in this case delta V is equal to 0. So it means work done between B and C, this is equal to 0. So simply we will take here, because work done is equal to 0. Now we need to talk about internal energy from A to B. From A to B, how internal energy is changing. But we need to understand delta U. This depends on delta T. Delta T. Delta U and delta T, they are directly proportional, because we have already discussed that change in kinetic energy, average kinetic energy, this is equal to 3 by 2 K times delta T. And this is for ideal gases. Ideal gases, they do not have potential energy, so they have only kinetic energy. So we can say delta U, this is also equal to 3 by 2 K times delta T. As 3 by 2 K is constant, so from here we can say delta U, this is directly proportional to delta T, temperature in Kelvin. So this is the point what you need to understand to find the change in internal energy. Now let's try to find out how internal energy is changing between A and B. So we can say delta AB, how this internal energy is changing. But internal energy, this depends on change in temperature. So we can use ideal gas equation. We can say T is equal to PV divided by NR. If you look at A and B, mean this process A and B, volume is decreasing, so we can write on volume is decreasing, but pressure is constant. N is constant, this is number of moles, and R is molar gas constant, this is also constant. So it simply means that temperature is decreasing. So if temperature is decreasing, it means delta U is also decreasing. So simply we will tick here. Now we will try to find out change in internal energy between B and C. So we will be using this formula again. So I'll be writing this time here. This T is equal to PV over NR. So if you look at change in volume between B and C, change in volume is constant. There is no change in volume. But pressure is increasing, and N is a constant, R is also constant. So as P is increasing, it means T is increasing. So it simply means that delta T is increasing. If delta T is increasing, it means delta U is also increasing. So simply this one is increasing. So this is a beautiful way how you can answer this type of problems. Second part says use the first law of thermodynamics to describe and explain the energy transfers associated with one complete cycle A, B, C, D, A. One complete cycle. So simply we need to write on first law of thermodynamics for one complete cycle. So for any complete cycle, or you can say for any complete cycle, or you can say in any complete thermodynamic cycle, delta U is equal to 0. So simply we can start with this one. We can say delta U, this is equal to Q plus W. We need to find out Q. Delta U in this case is equal to 0. So we can write on simply Q here plus work done between A and B. So we can say work done between A and B plus work done between B and C plus work done between C and D plus work done between D and A. So here we have Q and work done between A and B. This work done is positive because gas is compressed. So let me write on here. In this case, gas is compressed, it means work is done on gas, so this work done is positive. And here work done is equal to 0, and here work done is equal to negative because gas is expanding. So you can write down expand. Between D and A, work done is equal to 0 because change in volume is equal to 0. So we have WAB, this work done is positive, so we can say WAB, this is positive, plus we have 0 BC, plus we have WCD, and plus we have DA, this is equal to 0. Now simply we have to compare negative work done. This is negative work done because gas is expanding, so work is done by gas. So let me sketch this one here. Imagine that we have initially piston at this point and we have gas here, and then this gas expand and piston moves to this point. So in this case work is done by gas, so work done on gas is negative. So we can simply write down WCD, this work done is negative. So we can change this one here so you will not get confused. So let me write on here work done here. So this is work done between A and B. Between BC, work done is equal to 0, and this work done is negative. Now simply we need to compare which work done is greater. So if we look at change in volume between CD and change in volume between AB, change in volume means increase in volume and decrease in volume, they are the same. So we can say change in volume between AB, this is equal to change in volume between BC. One is positive, one is negative, but in magnitude, the change in volume is the same. Magnitude is the same. I'm talking about magnitude. Change in volume is the same. But if you look at P at AB, this one is lower. So you can also see from here, and we have pressure between CD. So this is lower than pressure between CD. So it simply means that from here we can write down work done by CD, means work done between C and D. This one is greater than work done between A and B in magnitude. We're talking about magnitudes. So as negative work done is greater, so it means the net work done. So we can say the net work done, W net, this one is negative. And if change in internal energy is equal to 0, it simply means that Q has to be positive. Q has to be positive. So it means in this process there is input of thermal energy. Mean thermal energy need to be added in this process. So this Q is positive. So thermal energy has been added to the system. I hope this one is clear to you. I try to explain you in detail, but concept is very simple. So this process, you see, I can in a simple way, if it is clockwise, so let me draw here for your better understanding. So next time you can do this question quickly. So PV, let's say we have one cycle. This cycle is here, so as it is given here. So this is clockwise. You can see this cycle is clockwise. In this case, net work done on gas always will be negative. And if we have cycle, let's say we have P here, let's say we have V here, again we have this cycle, but this time it is anti-clockwise. This is anti-clockwise. So in this case you can see this cycle is anti-clockwise, and in this case net work done on gas will be positive. So in this case thermal energy will be released. In this case thermal energy has to be added. So let me rewrite here. Let me write down also here. Q in this case has to be positive, and Q in this case has to be negative. So in this case thermal energy will be released from the system. So I can also write down here W in this case is negative, W in this case is positive. So you can also understand this problem like this. So in the exam you can save time. You no need to do these all things. You can simply understand if it is a clockwise cycle, work done is negative and Q has to be positive, because total change in internal energy in any complete cycle is equal to 0. And if it is anti-clockwise cycle, it means work done will be positive. So thermal energy has to be released from the system, because delta U for any complete cycle is equal to 0. I hope this makes sense to you. Now let me show you the answer, what you can write down in your final answer. In your final answer you have to mention these points, and this question has 3 marks. So first mark you will get if you have written more work done by gas in CD than is done on gas in AB, because the value of P between CD is greater, so work done is greater because change in volume is the same. And second point, you can say overall change in internal energy is equal to 0, so it means there must be input of thermal energy. So if you write down these 3 points you will get 3 marks. I hope this question is clear to you. If you still have any questions, please write down your questions in comments. I will try to answer as soon as